In the previous video, we learned how to convert mass to moles using the formula number of moles is equals to mass over molar mass. That formula is still important today. In this video, we are building on that by adding one more formula for gases at room conditions. At room conditions, or RTP, 1 mole of any gas occupies 24 dm cube, or equivalently 24,000 cm cube of volume. N of any gas is equals to V over 24 if the volume is expressed in dm cube, or number of moles of gas is equals to V over 24,000 if the volume is expressed in cm cube. The key idea is to recognize trigger word. If you see mass, mR, AR, you use the formula N equals to M over MR. If you see gas, RTP, room conditions, is an indication to you that the substance is a gas. You use the formula N equals to V over 24 or V over 24,000. Question 1. At room conditions, a sample of carbon dioxide has a volume of 9.6 dm cube. Calculate the number of moles of carbon dioxide. Carbon dioxide is a gas at room conditions, so I use the gas mole formula. N equals to V over 24. Substitute number of moles of carbon dioxide is equals to 9.6 over 24. So the answer is 0.40 mole. Question 2. At room conditions, a sample of hydrogen has a volume of 360 cubic centimeter. Calculate the number of moles of hydrogen. Hydrogen is a gas. Since the volume is expressed as cubic centimeter, so I must use 24,000 cubic centimeter. N is equals to V over 24,000. Substitute number of moles of hydrogen gas is equals to 360 over 24,000. So the answer is 0.0150 mole. Question 3. A sample of carbon dioxide has a mass of 22.0 gram at room conditions. Calculate its volume in dm cube. I see the word mass, I will think of number of moles is equals to mass over molar mass. Since carbon dioxide is a gas, I'll be thinking of number of moles of gas is equals to volume over 24. Since I'm asked to find its volume, this formula will be used last, and this formula will be used first. So I find the number of moles of carbon dioxide to be 22.0 over the molar mass of carbon dioxide, which is equals to 44, giving us the answer 0.50 mole of carbon dioxide. But I'm asked to find its volume in dm cube. Therefore, 0.50 is equals to volume over 24. Hence, the volume of carbon dioxide is simply 0.50 mole multiplied by the molar gas volume, which is 24 dm cube, giving us the answer 12.0 dm cube. Question 4. Calculate the mass of 12 dm cube of oxygen gas at room conditions. When I see the word mass, I'll think of number of moles is equals to mass over molar mass. Since we have a gas, I'll think of the formula number of moles of gas is equals to V over 24. Since I'm asked to calculate the mass, I know that this formula will be used last and this formula will be used first. So the number of moles of oxygen gas is equals to 12 over 24 equals to 0.50 mole. To find the mass of oxygen gas, 0.50 is equals to mass over the molar mass of oxygen gas, which is equivalent to 32. So the mass of oxygen gas is equals to 0.50 multiplied by 32. We apply the cross multiply technique. So the answer is 16.0 gram. Question 5. A gas has a volume of 7.2 dm cube and a mass of 10.8 grams at room conditions. Find the relative molecular mass MR of the gas. Since we have a gas, I will know that we have to apply the formula number of moles of gas is equals to V over 24. I see the trigger word mass and MR. I know I will have to apply the formula number of moles is equals to mass over MR. Since I'm asked to find the MR, I know that this formula will be applied last and this formula will be applied first. So we find the number of moles of gas as 7.2 over 24 equals to 0.30 mole. Then we apply the next formula. 0.30 mole is equals to the mass, and the mass given in question is 10.8 grams over the molar mass. The molar mass of the gas will be equals to 10.8 over 0.30 equals to 36. Hence, the relative molecular mass is 36. Question 6. Magnesium reacts with excess hydrochloric acid to produce hydrogen gas. First, we must produce a balanced chemical equation. Magnesium plus HCl produces the salt magnesium chloride plus hydrogen gas. Once we have balanced the equation, we'll be able to solve this question. 0.30 mole of magnesium was used. The question tells us that hydrochloric acid is the excess reagent, meaning magnesium is the limiting reagent. It is the amount of limiting reagent that determines the yield of the reaction, which in this case is the hydrogen gas. So based on a balanced chemical equation, the mole ratio of magnesium to hydrogen is 1:1. So the number of moles of hydrogen gas is also equals to 0.30 mole. Since hydrogen is a gas at room conditions, we apply the formula number of moles of gas is equals to V over 24. 0.30 is equals to V over 24. So the volume of hydrogen gas will be equals to 0.30 multiplied by 24. Hence, its volume is equals to 7.2 dm cube. So today we built on the previous video. Previously, we learned N is equals to mass over mR. Today, we added the gas volume at room conditions. The formulas are N is equals to V over 24 or V over 24,000. Learn to recognize trigger words such as mass, MR, AR, gas, RTP, room conditions. Then decide the correct sequence of which formula to use, and always try to find the moles first.